Welcome back to Arxflix. Today, we're taking a deep dive into a groundbreaking paper titled FairFace, Face Attribute Dataset for Balanced Race, Gender, and Age. This research tackles a pressing issue in face recognition datasets: racial bias. Most existing public face datasets are overwhelmingly biased towards Caucasian faces. This lack of representation adversely affects the accuracy of face recognition models across different racial groups. Here, you can see how existing datasets like LFWA and Saliba are skewed heavily towards white faces. This bias creates uneven performance across subdemographic groups, leading to ethical concerns and limiting the model's real-world applicability. To address this, the authors introduce a novel dataset titled FairFace. This dataset comprises 108,501 images and focuses on a balanced racial composition. It includes 7 race groups: white, black, Indian, East Asian, Southeast Asian, Middle East, and Latino. The images are sourced from the YFCCUA 0 and Flickr dataset and are annotated for race, gender, and age. This figure shows the individual typology angle, IDA, which measures skin color distribution for different races in the dataset. The paper makes 3 primary contributions. First, it empirically shows that models trained on existing datasets do not generalize well to data containing non-white faces. Second, the new dataset significantly improves performance not only overall, but also across racial groups. Third, it is the first large-scale, in-the-wild, face attribute dataset to include racial groups like Latino and Middle Eastern, setting it apart from previous collections. Here are some random samples from the FairFace dataset, highlighting its diverse and balanced nature. The authors meticulously built this dataset by adopting a race taxonomy, focusing on physical traits for race classification. Images from the YFCCUA 0 were supplemented with data from Twitter and various online newspapers to ensure diversity. The authors analyzed the racial composition of various datasets. Unsurprisingly, most datasets were found to be heavily skewed towards the white race. The FairFace dataset, however, maintains a balanced racial composition. The TSNE visualizations show how diverse and well-distributed the faces in FairFace are compared to other datasets. Models trained on FairFace were compared to those trained on other datasets like Arxflix, LFWA, and Saliba. The FairFace models not only performed better on novel datasets, but also showed consistent accuracy across different races and genders. This equation expresses conditional use accuracy equality, which FairFace models excelled at achieving. To test the generational performance, the authors used novel datasets from various sources: geotagged tweets from 4 countries, photographs from online media outlets, and images from a protest dataset. The FairFace models consistently outperformed others, proving the dataset's robustness. This measures the maximum accuracy disparity across subpopulations. FairFace achieved a much lower disparity, indicating fairer outcomes. The FairFace dataset is a significant leap towards mitigating racial bias in face attribute recognition. It sets a new standard for balanced and generalizable datasets, facilitating fair AI models. Thanks for watching. Make sure to like, share, and subscribe for more insights into groundbreaking research. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.